Welcome students. In today's video lecture, we will see pharmaceutical analysis part 1. This is for the first semester B Pharma. This is unit 1. So my name is Dr. Praneeth Vijayendran and I will go through this topic with you. So please follow carefully. So let's start this topic. So here I have provided first the outline of this video lecture. The outline for this unit is first I will give a brief introduction about pharmaceutical analysis because this introduction will take you to understand the topic better and go to the next level. The second thing I would like to talk about today in today's lecture is steps involved in chemical analysis. So, pharmaceutical chemical analysis. Then I will discuss about different techniques of analysis in the first chapter, and then I will move on to inform you about the methods of expressing concentrations and how to standardize this different solution of pharmaceutical chemicals. Then I will move on to see show you about what are the primary and secondary standard substances, and finally end this unit by giving you information about what are the errors present in pharmaceutical analysis. Okay, so let's start from first, that introduction of pharmaceutical analysis. So in the pharmaceutical analysis, what we study? So what are the things is needed to study under the pharmaceutical analysis topic. So the important thing what we study in this pharmaceutical analysis is how to identify the compound, chemical compound, or even the chemical compound includes drug molecules also, right? How to identify the drug molecule, how to purify these chemicals, and also how to quantify. Quantify meaning, quantify is how much amount of substance A. For example, if a drug contains two different substances, okay, how much the two different substances may be A, one first substance, and second substance may be B. So how much amount of A is present in the drug and how much amount of B is present in the drug. This can be drug or in any chemical substance also. So in the pharmaceutical analysis, we will identify what are the chemicals involved present in that substance, how to purify and how to quantify these chemical compounds. Then we use different techniques in the pharmaceutical analysis. So what are the techniques? A technique can be either manual, right? Manual means we weight. What is the weight? So manually we weight in the balance. Okay, this is one technique. And then, for example, if you have a drug contain compound 1 and compound 2, compound 1 we weigh it, compound B is, if it is a liquid, we will measure it, how much ml is present, like that. So it's a manual technique. Second one is a chemical technique. Chemical meaning we will react a substance with another substance, or we can test, like put a drop of another reagent and check any color change. We find out what is that substance. So this is indicator technique, the chemical technique, and also instrumentation technique. So, so we can use some instrument and see, put that chemical there and find out what is that chemical, for example. So identify and quantify how much substance is present using this technique. Then what method we can use in the pharmaceutical analysis? So there are two methods we can use. One is the qualitative analysis method, and the second one is quantitative analysis method. So I will teach you this what is quantitative, what is qualitative, examples, some examples in the next part of this lecture. So let's have a look at what is this qualitative and quantitative analysis. So as I mentioned, there are two different techniques, methods in the pharmaceutical analysis. One is the qualitative analysis, and another one is quantitative analysis. So first let's see the qualitative analysis. So what is qualitative analysis? So qualitative analysis, we will analyze an unknown sample. So means we don't know what is that sample is. Okay, you can see in that picture, in this picture, you can see a analyst, or means a lab technician is there are many 1, 2, 3, 4, 6 chemicals are there. We don't know what are these chemicals, and he is testing with something, right? Some reagent is testing and find out what is inside that one. So unknown sample is analyzed in this qualitative analysis. Next is the presence or absence of a substance can be determined using this qualitative analysis. So, for example, if you are looking for some chemical present in this, let's say in the first in the first flask, okay, the first flask. So he is adding a reagent and find out whether he wants to find out whether there is a particular substance, chemical substance, is present or absent in this flask 1. So, what in the qualitative analysis, a presence or absence of a particular substance can be determined. This is very important point. And the third point is, but the amount, how much amount of that substance. For example, if you find out a substance, okay, but you don't know how much amount of that substance is present in that sample, and how much purity of this particular substance is present in this sample, you don't know, and other details. So, in the qualitative analysis, we only find out the particular substance is present or not. I will give an example, this qualitative analysis, so you can better understand this, what is actually the definition of the qualitative analysis. But in this slide, you can see that qualitative analysis simply tell you whether a substance is present or not. Only that, no other detail, like how much some amount of the substance is present, or how much purity, how much pure is a substance. Okay, so this is the qualitative analysis. Only show you the substance is present or absent. So I have given an example here. So in the right hand side, there is a conical flask with something inside, okay, but we don't know what is that. Some chemical is inside that. So here it is, I have mentioned, it's an unknown chemical. It can be an acid or base, okay, but I don't know whether this is acid or base. Okay, so what I can do is I can add this reagent, this indicator, phenolphthalein. We also do this experiment in the lab, right? The students can also do this. You add this phenolphthalein inside that. So what we can do is add this phenolphthalein inside this flask. So when I add, for example, I got a pink color. The right hand side, you can see that I got a pink color. So the pink color indicates that it's a base. It is a base, not acid. But if it is acid, there will be no color. Okay, so I got a pink color. That means this contains acid. This in the left hand side, it's contain acid. So the pink color indicates the presence of base. Okay, so the presence or absence of a chemical is determined, right? Because I know that in that one, in this flask, there is acid is present. Base is present, not acid. So the presence or absence of a chemical meaning acid or base, right? So acid is not present and base is present, but I don't know how much pure this is. Okay, how much base is present in that one, I don't know. Maybe it contains 50% of base and some with some water, or some with other chemical also, we don't know. But I know only that it contains base using this experiment. How much purity and others are not determined in this qualitative analysis. So this is an example to clearly show you that what information we gather from this qualitative analysis technique. Okay, so let's move on to see what is the next technique, next method, right? The quantitative analysis method. Let's see. So what is the quantitative analysis? Here also the same thing, unknown sample is analyzed like in the qualitative analysis. Like unknown sample is analyzed. So the presence or absence of a substance is also determined here. This is second point. But in this case, there is a special thing, the quantitative analysis. We know how much amount of a substance is present, first point, right? How much amount of substance is present, how much pure is the substance. It is 80% pure or 90% pure, everything we can find out using this quantitative analysis. So you can see in this picture, this particular lab technician or scientist is analyzing very carefully. In this sample, is collecting and is analyzing everything very carefully, all the data, how much is present, what are the chemical inside this one, what is the structure. This we can see from this illustration picture. So what is quantitative analysis? The same is unknown sample is analyzed, presence or absence of a substance can be determined, and their amount, purity, and all the other details, structure and everything is also determined. So we get a complete picture, complete information of a chemical. So quantitative analysis is a very important method for pharmaceutical analysis, because for the drugs we need to know the purity, amount, everything, the structure and the chemical. There is any other thing, there's more detail is needed. So it is a complete information you can get from quantitative analysis, and for the qualitative analysis you only get a very simple information, that is a substance is present, a chemical is present or not. So I will give an example of this quantitative analysis here. So this is an example. So here I have taken this unknown chemical. So I don't know what is this chemical is. Okay. So I have written also it's an unknown chemical. So when I analyze this chemical, this drug for example, so I crushed it and make it as a powder first, and then I try to identify, and then I analyze and get the identity of the chemical is determined. So I know now what is this chemical. In addition, I also found out that the purity and how much amount of this chemical is present. So both the identity and the amount and purity is determined here. So this is what I have shown in the right hand side, that is the structure. So now I know the structure of this this unknown chemical compound by analysis. There are many analysis, we will discuss about this later. But now which I can check, you can just think that it is I have done some analysis, some pharmaceutical analysis, and I found out this is the structure of this chemical. So if I find out the structure by using some method technique, so I know also the name of this chemical. That is, for example, this chemical is present in this unknown sample. Let's take for an example. The name of this is salicylic acid. And then after further analysis, I also found out this structure. Okay, this is structure. Okay, I found out. For example, you can use the NMR technique, which we will study in the later semester, and find out the structure of this compound. And also I found out the purity of the compound. How much pure is this compound is 90%, 95% of pure and how much quantity, how much amount of this substance is present by using this quantitative analysis. So these two important methods you should thoroughly understand the difference and the importance of this qualitative and quantitative analysis. So now let's move on to the second subtopic, that is steps involved in the chemical analysis. Steps involved in chemical analysis. There are different steps, many steps are available. We have to follow to analyze a chemical compound. So here I have given 7 important steps involved in this analysis. The first step is sampling. So how you sample a chemical. Okay, so normally the analyst meaning a person who is analyzing the sample. A scientist, can be a scientist, chemist or pharmacist, is an analyst. So he is an analyst, and he will how he will sample. Sampling means he will select a sample, and he will determine how much sample has to be taken. For example, if you want to analyze a sample, so if you want to first check the qualitative analysis whether it is present or not. So you will take a little bit amount, right, to test whether it is something is some chemical is present or not. But for complete analysis, for quantitative analysis, so this analyst will take the required amount, the more amount of sample. So this is sampling. How much sample we need to take, or what is the nature of the sample, whether it is solid, liquid, or everything is determined, or gas is determined by the analyst. The second step involved in the chemical analysis is sample preparation. So what is sample preparation? Sample preparation is the analyst, the person who is analyzing the sample, will prepare the sample by mixing with some other binding agent, for example, dry the sample before analyze, because if the sample is very hygroscopic, it absorbs moisture, you need to dry the sample, right, first. So this analyst will dry the sample in an appropriate method before analysis. This is the sample preparation, and then he will prepare this sample accordingly. The third step involved in the chemical analysis is processing this sample. So how to process the sample? By heating the sample, okay, to remove any unwanted, easily evaporated volatile compound. For example, if a chloroform is present in a sample and you want to remove that chloroform, we can just simply heat it and remove the chloroform. Chloroform will easily, is a volatile compound, it will easily go away as a vapor. And another method is processing a sample is dissolve the sample to make a solution. So if you have a solid sample and if you want to make it as a solution, okay, so you can dissolve in water or any other solvent to make a solution. So this is the sample processing sample. And also purify the sample before analyzing. Some impurity will be present, we need to remove it by different methods. These are all involved in the third step of processing the sample. And in the fourth step, the analyst will select a particular technique according to the need of the analysis. Okay, there are many techniques available. So analyst will take a appropriate technique, and then, for example, here I have given a volumetric technique where we can add some solvent, acid, base, or anything, and then find out how much is the how much compound is present. Gravimetric or spectroscopic technique, which will go further detail about this terminology. But here I have only given important point is analyst will select an appropriate technique for analysis of the sample. And then analyst will also analyze the sample, right? This is an important point. The analysis can be done through calibration, optimization, sanitization, and measurement of substance like boiling point, melting point, and everything. So in the analysis of sample, it involves all the important analytical methods like optimization, sanitization of the sample for complete analysis of the sample. The sixth point is calculation and result. So the analyst will, after analyzing the sample, the data is processed by calculation, either through a computer or simple calculation using a calculator, and then he will get results. These results are finally tabulated, right? This result should be tabulated. So these results are presented in the form of data appropriately, either through some table or and the data is processed after calculation to get result, and then displayed through table or presentation or any other means. These are the final step in the chemical analysis. So there are important 7 steps involved in the chemical analysis. That's what we have seen. So coming to the next subtopic is the concentration of a chemical substance present in the chemical substance. How to find out this concentration of this chemical substance? So what is the concentration? So concentration, for example, what is the concentration of a substance? So concentration meaning is how much amount of solute is present in total volume of a solution. Okay. So this may be a new words for you. What is solute? What is solution? So better we have to understand what actually this meaning. What is solute? What is solution? What is solvent, etc. For this, I have provided here the definition, and also I will give an example of to understand really what is meaning the solute, solvent, and solution. So first let's see what is a solute. So a solute is a substance, usually a solid, normally a solid, but it can be liquid and gas also. A substance, usually solid, that can dissolve easily. That can be dissolved easily. Okay. What is solvent? The solvent is a substance. Usually it is liquid. Okay. Normally the solute is a solid, and solvent is normally is a liquid that can be used to dissolve a solute. So solvent is used to dissolve the solute. Okay. And finally, what is meant by solution? Solution is nothing but a mixture of solute and solvent. So solution is solute plus solvent. So with this, I have given as a very normal example. Everybody knows to understand what are the different meaning of this solute and solvent. So let's take salt, normal salt. Okay, and in this bottle, and also take a water in a beaker. Okay, here I have shown this two diagram, salt and water. Salt is solid. Okay, and solid normally is a solute, and solvent is water. So water is a solvent. So water solvent is used to dissolve the solute, right? So what we can do is add this salt into this water. You add this. So what will happen? Salt will dissolve in water, right? So salt is dissolved in water, and this is what we get: salt plus water. So salt plus water is a solution. So solution can be prepared by dissolving salt and adding into dissolving salt in water to get this solution. Salt plus salt solution meaning salt plus water. So this simple example you can remember to understand the different names: solute, solvent, and solution. So let's move on to the second example also. So this can not only be a salt or anything, but it can also apply to chemicals and drugs. Okay, so let's say for example we take the copper sulfate as the salt. Okay, copper sulfate, and then we add. So this is a solute. This is a solid, and then we add into this water, beaker containing water. So what you will get? We will get copper sulfate solution. Copper sulfate plus water. That is a solution. So this not only applied to simple salt, but it's applied to chemicals, copper, inorganic chemical, organic chemical, anything. So this solute, solvent solution can be prepared by using chemicals and salt and acid, base, and everything. So we can understand this easily. So next one is you need to make a solution, right? So you have to prepare solution. So in this picture you can see two solution was prepared in this flask. One is in the conical flask, and then another one is in the standard measuring flask. So how to prepare a solution? So there are before preparing the solution, you need to understand different expression to for preparing the concentration, different concentration terms. So the first one is the molarity, to express the concentration. So it is called as molar concentration. Okay, this is the one way to express concentration. Concentration meaning how much amount of solute in solution, right? So that is this, and this one way to you can represent a concentration is by through this term called molarity. This is called as molar concentration. Similarly, there are other methods. Methods you can express the concentration of a solution for preparing the solution, preparing the chemical solution. Second term is molality. It's also called as molar concentration. Third one is normality, normal concentration, You can also express the concentration by percentage. How much percentage of A is present, right, in the solution. So this is another method to express concentration. It's called percentage or percent concentration. And also I have given one more way we can express the concentration through ppm. It's called as parts per million. How many parts of A is for a chemical is present in a million. So this is a different way. We will see in today's class only the first one, that is molarity for expressing the concentration. And also we will see one example, one or two examples in this case. So what is molarity? I already told it is a molar, also called as molar concentration, right? So definition is the number of moles. Molarity is number of moles of a solute, present in per liter of the solution. Okay, it is expressed by a capital M. Capital M is represented for molarity. Okay, here this is the formula expressed here. Molarity M equal to number of moles of solute. Okay, what is solute? Solute is a substance which is used to, which can be dissolved, right, easily dissolved. So it is normally a solid. So molarity is number of moles of solute. We will see what is moles in the later. So number of moles of solute per liter of the solution. So volume of solution in 1 liter, in per liter, in liter. So this is the formula. So let's take an example of a molarity of a chemical and then see how to calculate the molarity. So this is a calculation example number 1. Let's see how you can prepare a 2 molar solution of a sodium hydroxide. Sodium hydroxide formula is NaOH, right, in a total volume of 1 liter of water. So how we can prepare this solution? The concentration is 2 molar, right? It is expressed 2 molar concentration means the solution concentration is 2 molar. But we need to know how to prepare this 2 molar solution of NaOH in 1 liter. So in 1 liter. So we already know this formula. Molarity is number of moles per solute, number of moles of solute per volume of a solution. So what is solute here? Solute is sodium hydroxide. Right, it is a solid normally. Solvent is water, right? It contains a large amount. So total volume should be 1 liter. So we do use water, and the solution is sodium hydroxide plus water. This is the solution. So first we have to calculate the number of moles of NaOH needed. So number of moles, we know this in this formula. You can see we know what is the molarity of this solution, 2 molar. So molarity we know. Volume of the solution, total volume is 1 liter, we know. So we need to find out what is the number of moles of solute. So how to find out that one? We input this value. Okay, this molarity is 2 molar. Here I have written here, and the volume of the solution here I have displayed is 1 liter. So number of moles is 1 into 2 molar, right? 1 liter into 2 molar, that is number of moles is sodium hydroxide is 2 mole. Okay, 2 into 1, 2 mole. So we found out what is the number of moles of sodium hydroxide present in the 2 molar solution. So now what we need to do? We need to calculate the weight of sodium hydroxide needed to prepare this 2 moles of sodium hydroxide solution, or 2 molar solution of sodium hydroxide, right? So how to find out this number of grams? So we have to use the second formula, that is this one, number of moles of sodium hydroxide. So number of moles equal to weight of sodium hydroxide, here weight sodium hydroxide in gram divided by molar mass of sodium hydroxide. Molar mass we already know. Molar mass of sodium hydroxide, if you check through internet, it is 40, right? 40 gram per mole, that is the molar mass. We know already. We just calculated the number of moles of sodium hydroxide, right? Previously, just in the previous slide, we have calculated that is 2 mole. So we just input this value 2 mole. Okay, this one we have calculated, and this is already known in the literature or in the internet. You can find out the molar mass of sodium hydroxide. Okay, and the weight now we can calculate. 40 into 2 is 80. We will get 80 gram, right? Weight of sodium hydroxide will be 80 gram. So what we found out is 80 grams of sodium hydroxide is needed to make the 2 molar solution. So what you have to do, 80 gram of sodium hydroxide you need to weigh in a balance and then dissolve in water, make it to 1 liter, and that will give you a concentration of 2 molar. So now you know how to calculate how to prepare a solution, okay, with a known concentration, with a determined concentration. So let's check whether you can able to do how to prepare a 2 molar solution. Same thing, right? This is 2 molar solution. That also previous, this is example number 2. In 2 liter, how to make it in 2 liter? Previously we made in 1 liter, now we can make it in 2 liter. So you can try without seeing this, you can try based on the first example, try to solve this question. But I will show you how to make this same formula, how to make the solution. Same formula you use for molarity, number of moles of solute by volume of solution. Solute is sodium hydroxide, solvent is water, solution is sodium hydroxide plus water, right? So first we have to calculate the number of moles of sodium hydroxide needed. So here this we already know the concentration, the molarity, that is concentration needed. 2 molar we need to make. The number of moles of sodium hydroxide is we need to find out. And here the volume of solution is changed now. Previously it was 1 liter, now it is 2 liters, so I put 2 liter here. So what is the number of moles of sodium hydroxide? Now number of moles of sodium hydroxide needed to prepare this is 4 mole, right? So number of moles of sodium hydroxide we found out that is 4 mole in this second example. And finally need to calculate the number of grams of sodium hydroxide needed to make the 4 mole of sodium hydroxide. So we use the same second formula, number of moles formula, and we plug all these numbers. 4 mole, right? 4 mole we found out here, and the molecular mass of sodium hydroxide is 40. We can get the weight, that is 160 grams. So we need to, previously we have 80 grams of sodium hydroxide needed to make 1 liter. In 1 liter to make the 2 molar solution. Now we have to get the 160 gram of sodium hydroxide to make 2 liters of 2 molar solution. So this is actually 2 molar, not 1 molar, sorry. So this is how the simple calculation and understand all the steps to make the solution. So in the this is all for this video lecture, this class. And next class we will see other terms, concentration terms, and we also see some examples how to calculate a concentration of a particular chemical by using this different terms. And yeah, thanks for showing the attention, and I will see you in the next class. Thanks.